Hi, my name is Jasmine Chang, and today I'll be presenting about whale tails. Each humpback whale has a unique tail pattern, like a fingerprint. The challenge of this project was to identify a whale based on a picture of its tail. In the dataset, there were 10,000 images of 4,000 whales. The real-world application of this challenge is facial recognition. Like the whale's unique tail patterns, people have unique faces. Similar techniques, particularly Siamese networks, are used in both cases. My project is also an example of one-shot learning. While many neural network systems rely on hundreds of thousands of images or data points for each class, this project only had a few images per class. So there was a difficulty with the data that I was using. Over 2,000 whales only had one picture of each whale, and over 1,000 whales only had two pictures of each whale. Therefore, it was important to refine the data to ensure that the neural network could actually converge. This included removing duplicates and pre-processing the images. The goal of a Siamese network is, given a pair of input images, determine whether that pair is a match or not matching. So here is the Siamese network model. It takes an input of an image pair labeled either matching or not matching. Each image is individually run through the neural network model, which outputs a feature map consisting of a 512-dimensional vector. Then, the difference is found between the two feature maps. A low difference means that the images are probably matching, while a high difference means that the images are probably not matching. The model's prediction is compared with the actual label. This process is repeated with thousands of image pairs. Over the course of the training cycle, the model learns and automatically adjusts its weights to better identify the features that matter. After training, the model reached about 80% peak accuracy. So next we're moving on into identifying whales. The goal is, given an input of a test image, which is an image that the model has never seen, output the whale ID. I tried 3 different approaches with varying levels of success. The first one was k-nearest neighbor. The second one was a classification layer with a softmax activation. The third one was the softmax activation with a center loss, where the model would learn a center for the features in each class. Here are my main takeaways from doing this project. First, when working with difficult data, it is important to filter the data and pre-process it in order to ensure that the network can learn. Second, it's to be open to research and learning. And lastly, it's to experiment with different ideas and different techniques, and through the process to be patient with yourself. Thank you for listening to my presentation. Thank you to my mentors Jin Lee and Hongji Lee and the Microsoft High School Intern program.